Okay, so I'm going to go over a couple of equations here that are related to friction, just introduce them. You're going to need it for some of the calculator pad stuff you're doing. And so just to review, you should have already had this in the past, but friction is a force opposing motion between two objects. Oftentimes it's good for us, keeps us from falling down and helps us go around curves and helps our cars go forward and that kind of thing. But we also can quantify it. And I want to try to show a little thing here to introduce this idea. So if we were going to tow, if you can imagine that this is sort of the ground, this is downwards, and an object is getting just pulled along, and it's getting pulled. Imagine different surfaces that it can interact with. Imagine a super smooth surface like this. The force of gravity is pushing these together, so they're getting pushed together, so there would be some kind of friction there that would be in this direction. So the friction would always be in this direction if we're moving to the right. The friction would always be to the right there, but as you go over different surfaces, there might be a little bit more friction here because this is kind of bumpy. And then if you got something really bumpy here, and if you could zoom in, really both surfaces are at play. You might have these little, if you zoom in on anything, it's not really smooth, but there's little bumps, and they kind of lock together, and the more they interact, the more friction you get. And the way that we quantify that in physics is we straight up just do a ratio. And so if you can imagine, the force of gravity is what's pulling down on this. And what is always, when something's not accelerating downwards or upward, what is combating the force of gravity is the force normal. Sometimes these are drawn backwards. Oftentimes they're drawn like this with the force normal. They're in force gravity. They're going opposite directions. It's common to show the arrows coming out of the center of the object. But for the sake of this, sometimes I think it's helpful to see that force normal is pushing that way. Gravity is pushing this way. The way we can quantify friction is with this equation. This equation right here is the force of friction is equal to the force normal times mu. And mu is really just a coefficient. It's symbolized with mu. This is a Greek letter, mu. And it's really the ratio of the force normal to the force of friction. So what that would actually look like is this is also written as, and this is what I mean by the ratio. So if you can see that, and this is how these the coefficient of friction is actually arrived at. They'll take, well, what is the force of friction? Remember when we're back here on our object, if we were pulling to the right here, what would this force of friction be? And we could compare this number, we could measure it and compare it to the force normal. And that's where that coefficient comes from. But oftentimes that mu is just a published value, as I'll show you in a second. One thing that you need to bear in mind is most of the time when you're dealing with friction, if not all of the time in an introductory physics class like this, if you're trying to calculate friction, force of gravity and force normal are effectively going to be the same thing. That's because you're not dealing with something that's accelerating upwards or downwards. Especially in the beginning here, it's worth thinking the force of gravity and the force normal are the same thing. There's times when things get on an incline, they get a little different. But when we move to one of these questions, and this is one that you're going to see, it says, consider the free body diagram for the object accelerating across the surface. The object has a mass of 2.91 kilograms, so I can add that. There's a forward thrust of 43.1 newtons. So this is 43.1. This is given to us in the problem. The coefficient of friction between the object and the surface is 0.33. And that's where, if we go back to this, if we remember that mu stands for the coefficient of friction. So I'll just go ahead and write that to the side here. Then it's going to ask us to determine some of these things. And the first thing it wants to know is the force normal. And for us to do this, we really have to make an assumption that the force normal is equal to the force of gravity. We can make that assumption because it's accelerating across the surface. It doesn't say it's accelerating upwards or downwards. So we assume these two things are the same. And we do have an equation for the force of gravity, which is right here. Force of gravity equals mass times gravity times g, which is 9.8. And so to do this first one, okay, so I put some things down here to sort of speed up this video. To do this first one for normal force, you of course need to know the force of gravity is equal to the force normal, as we discussed. And we have an equation for force of gravity. Force of gravity equals mass times gravity. And so we start putting in what we know. Force of gravity equals, our mass is 43.1 newtons. Sorry, 43.1. Oh, I just about made a mistake there. Since I said newtons, that helped me catch it. Our mass is 2.91 kilograms. And then we're going to multiply that times 9.8. Now, technically, the force of gravity is negative 9.8. And if we did keep the negative in there, we would just get a negative answer, show it's pointing down. Just for simplicity's sake, I'm going to leave that out of there. And so here we would find that the force of gravity is going to equal 28.52 newtons. And so we could put this up there, just like that. Now, it's saying, well, what is the force of friction experienced by the object? And this is where we got to go back to our equation. Force of friction equals force normal times mu. And we, in fact, have everything we need to solve for that. So we have our equation. Force of friction equals force normal times mu. I put in our force normal from here, and I put in our coefficient of friction, which was given to us in the original question. Of course, I wrote it down here. And we find that the force of friction is going to be 9.496. Now, we can always round this off, so this is going to round to 9.50. So we've got that rounding to 9.50. At this point, we really could put in this number over here. We could put in all of our numbers that we have here. 28.52. Those are equal, 28.52. When you're doing this, you should be drawing this out and writing these in. This is what good work would look like. I printed it out, but you could draw this thing on your paper, and you should. The force of friction would be 9.50 newtons. We shouldn't keep our units on there. Newtons, newtons, newtons. Now, it says, what is the force net experienced by the object? Back out a little bit here. So basically, this is saying, well, what are all these forces? Well, these two forces are the same, opposite direction, they cancel out. These are not the same. So here we're going to have to subtract. And you can just use this equation if you need to, if you really like equations. Force net equals force applied minus force of friction. You also can kind of just look at the picture and think through, if we're having tug of war here, what would happen? Of course, this would be 0. Tug of war here, well, this one's pulling harder. What's the difference between these? If you put these numbers into the equation, you may or may not get a negative answer. In our case, our applied force, we're not going to get a negative, but if you said, if we ended up with the applied force being less than the friction, where in this case it would be doing something else, you could get a negative number. That's just telling you which direction it goes. So our net force is going to be 33.60. And of course, this is going to be, you'll want to know, it's going to be to the left. The answer here is asking for acceleration of an object. This goes back to your original equations that we have for Newton's second law. This is the same equation. Just use this one because this is already solved for acceleration. So we can say acceleration is going to equal force net divided by mass. Our force net, as we just determined, was 33.6. Our mass was 2.91. And so we'll find our acceleration to be 11.55 meters per second. All right, and that's how you would solve. This was, by the way, if you're caring about numbers, this was Newton's laws 11Q1, but it's actually number 3 from our assignment from Newton's law 7. Thank you, like and subscribe.